Hello there, welcome to this section of Food Science and Technology 3. We are continuing with the chapter on dairy technology, milk and milk products. So today we are unpacking 3 products that exist because milk is brilliant, but milk is also perishable. So the theme is simple: remove water and you control microbes. So let us start with evaporated milk. Like the can on the slide, the key idea is concentration. So we remove water so the solids go up. In industry terms, evaporated milk is concentrated to about 2.25 times the solids of normal whole milk. Now I want you to walk with me through the process in plain language. As we've already articulated previously, raw milk is clarified so to remove physical dirt and sediment. Then it is concentrated by removing the water. So it is often fortified with vitamin D. So you, as students of food science and technology, I would like you to investigate and research what is the difference between fortification and enrichment. So once it's been fortified with vitamin D, it is then homogenized so that the fat stays nicely dispersed, and then it is filled into cans. So after the filling process, these cans are then sterilized, or the milk is sterilized in the can. And typically this involves a continuous pressure retort at about 118 degrees Celsius for around 15 minutes, and then there's a cooling process. So here is an interesting part. The heat that is applied there is not just merely for safety reasons, but it also changes and modifies the quality of the product. So now this heat is going to give this intense evaporated milk that has got this cooked, slightly caramelized color and flavor. So this product has now different characteristics. That is why some people love it in coffee, and then of course some people say it reminds or it tastes like childhood trauma. I don't know. What do you think? So if I take evaporated milk and add an equal amount of water, do I get back to something like fresh milk, or do I get something totally different? What do you think? I think the answer is yes. Roughly in terms of concentration, you get something closer to milk, to the whole milk or to the raw milk, but not in flavor and not in the history of heating. So what processing does is that it leaves fingerprints into the product. So now there's a modern variation or version of this concentrated evaporated milk. Instead of sterilizing the milk in the can, the milk can be sterilized using ultra heat temperature processing, and then it is filled into aseptic canning. So what happens is that in that route, you typically avoid some of the cooked flavor and color, depending of course on the exact time and temperature profile. You see, with these kind of products, there's one common problem that you have with concentrated milks. And this problem is that when you heat them and store them, the proteins begin to gel and thicken over time. So this is proteins saying we've had enough. We are now forming networks while you are storing the product. So how do the industry manages this problem? This problem is managed by strategies like pre-warming treatments and small addition of stabilizing salts. So here what they do, they often add things like phosphates and sometimes membrane processing to tweak the composition slightly. The honest truth is you can minimize gelation, but the total elimination of this problem is very difficult. So, in the South African context, evaporated milk is a shelf-stable dairy option that makes sense for example, in spaza shops, in rural supply chains, and even in student kitchens. When the cold chain is unreliable, a can becomes a very practical piece of food technology. Now I want us to move to sweetened condensed milk. So this one is similar, but the preservation mechanism and logic is slightly different. Here is the big statement here that I want you to know with this type of milk. It is not sterilized in the same way as evaporated milk. Instead, what they do here, you control microbial growth mainly by the addition of sugar. You see, because sugar reduces the water activity, in other words, it makes the water less available for microbes to use. So then the question is, how is it made? So you start by pasteurizing the milk, you concentrate it to remove the water, then you add sucrose. So the concentration and sugar addition are just to get about 63% of the sugar in the water phase for the final product. So this is a powerful preservation system because microbes, basically what happens is that they will arrive there and then realize that, hey, shucks, there's no free water for us. Hey, we then need to move and live our best life somewhere else. So if that is the case, why don't we do this principle with everything? And I think you know the answer because you've been doing food science and technology under my leadership for quite some time. The answer is simple. The product becomes very sweet, and sweetness is a feature that only applies to certain applications. See, in the South African context and food culture, sweetened condensed milk is mostly used in desserts across South Africa. I mean, there's this dessert that people like to have in Christmas, which is called the peppermint crisp tart, the fridge tart, the caramel treats, and many other baking applications. So in food processing terms, so these kinds of products brings sweetness, solids, body, and a very particular dairy note that is very hard to replace. I also want you to note the historical point here. Preservation by sugar, we know it has been around for a very long time. So we made the example of canned peaches and all of those things. So, but in many product categories, this kind of preservation by sugar was later replaced by preservation using heat and packaging technology. And I think you would agree with me that if you work at Woolworths, at ShopRite, both they still exist because they solve different problems and meet different consumer preferences. So now, let us turn our attention to talk about milk powder, which is essentially milk that is taken to a very high solids content, typically around 97% solids. So the aim here is clear: long shelf life, low transport cost, and flexibility. But the question is, how do we get there? We get there through a process which is called spray drying. You've done drying in food science and technology too, so you should be familiar with this. And sometimes it's also done using vacuum drying for certain niche products. Spray drying is an efficient and scalable technology. That is why it dominates globally. But milk powder also has its own challenge. Over storage, it can develop off flavors which are often described as oxidized or cardbox-like flavors, especially in whole milk powder because fat oxidation is involved. And here's the point that I want you to remember. This oxidation is not fully solved. We can reduce the off flavors through good processing and packaging, but completely removing them under storage conditions is still a huge challenge for the food industry. Commercially, skim milk powder, remember skim milk, we remove the fat. It is often more important than whole milk powder for many product formulations because with skim milk, it is more stable and fits many applications. Whole milk powder still matters, but it is not always the first choice for beverage quality products. So in South Africa, milk powder is central in many processed foods, from baked goods to sauces to confectionaries to reconstituted dairy drinks. It also makes sense in settings where refrigeration is limited and where transportation costs still matters. And this product is literally milk engineered for logistics.